Hello, you guys. Let's talk about Chapter 10, Lesson 2, three-dimensional figures. So our goal here is to classify. That means name and sketch these solids, these 3D shapes. So a solid, anytime you hear me say solid, that just means I'm talking about a three-dimensional shape. And here's one that's a prism, and here's one that's a pyramid. And polyhedron just means it has many faces. A face is just like one side. Think of it like the wall of a building. Now a prism has a top and a base that are congruent and parallel. So see how the floor is a triangle and the ceiling is a triangle. They're congruent, that means they're exactly the same shape, exactly the same size, and they're parallel. They would never ever touch. Now a pyramid has a point for the top. So it has some shape as the floor, but it has exactly a top, a point at the top. Okay, and a cylinder, you've heard this before, that's over here, and that just means that the top and the base are circles, and they are parallel. So they're congruent circles, and they're parallel. They would never touch each other. All right, and then a cone, I always like to think of an ice cream cone upside down. So here's a cone. And then a sphere just looks like a ball. You've seen that. And then an edge is where two faces meet. So two of the walls intersect. So this is an edge right here. A vertex is a corner point. And so that could be where three walls intersect in a corner point. And then three or more walls, I should say, intersect. Now, a diagonal of a polyhedron is a line segment that goes through the solid. Right, like this yellow line is a diagonal. Okay, so the best way to classify or name solids is you want to look for the bases, okay? And the bases have to match, or the base, think of it like the floor of the building. Now notice here, when these triangular bases match, and they would never intersect, that's what we call a prism. So this, we would name it by the base. It's a triangle, so we'd say a triangular prism. The prisms have two congruent bases. That means the triangles are the same. That lie in parallel planes. That means they would never intersect. And the other faces, all the other walls are rectangles. Okay, now a pyramid has some kind of a floor, some kind of a base, and then they only have one base. Notice how the top is just a point, and all the other faces are triangles. So this would be, if this base is a rectangle, this would be a rectangular pyramid. Now a cylinder is pretty easy to spot. It has two congruent circles as bases. And a cone is easy to spot. That looks like an upside down ice cream cone. That just has one base that's a circle, and the top is a point. And then a sphere, looks like a ball. Okay, take a look at example 1, classifying solids. Classify the solid and tell whether it's a polyhedron. So this solid has one circular base right here. I shaded it with blue. So it's a cone, and it is not a polyhedron because the circle is not a polygon. A circle cannot be a polygon because a polygon means it has edges, and a circle doesn't have edges. Take a look at the guided practice. Classify, that means give the best name of the solid, and then tell whether it's a polyhedron. So I shaded the bases here. So look at number 1. The bases are triangles. So this is a triangular prism, and yes, it's a polyhedron because a triangle has edges. This, I see two circles that are parallel and they match. So this is a cylinder, and it's not a polyhedron because circles don't have edges. And this, of course, is a sphere, and it's not a polyhedron because circles don't have edges. Okay, and you can lightly cross off example 2, and this is where you're going to put your movie clue over here. All right, take a look at example 3, counting faces, edges, and vertices. So they want us to classify this solid and then count the number of faces, edges, and vertices. So the way I classify it is I use my blue and I shade the base. And I notice that the base has 1, 2, 3, 4, 5, 6 sides. So a 6-sided shape is called a hexagon. So this is a hexagonal, and then because it has a point at the top, it's a pyramid, not a prism, it's a pyramid. Okay, and so now let's look at this. To count the number of faces, I have to count all the walls, including the floor. So the floor is one wall, and then there are 1, 2, 3, 4, 5, 6 triangles that make up the walls going up. So 6 triangular walls and one base makes a total of 7 faces. Now for the edges, this is where, all the edges, all the sides of the walls, the edges. So if I go around the bottom, always start with the base and go around the bottom. I count 1, 2, 3, 4, 5, 6 edges on the base. And then count the edges going up. 1, 2, 3, 4, 5, 6 edges going up. Well, 6 plus 6 makes 12 edges. Now with the vertices, remember you're counting the corner points. So here I would always start at the base. That's the easiest place to start. So I count 1, 2, 3, 4, 5, 6 corner points on the base, and then there's just that one at the top. So there's 6 base corner points and 1 point at the top. That makes 7 vertices. Okay, so a lot of people ask me, how do I sketch a solid? And they want us to sketch a rectangular prism. So this is what I do. The first step is start with the front of the building, the front wall. And I know it's a rectangle because it's a rectangular prism. So draw a rectangle in this box. Now, the second thing I do is I go to 3 of the corner points, 3 of the vertices, and I go back at an angle. So go back. And then the third thing I do is I connect the back dots, okay? And then you want to make dashed lines to see kind of the back, to see through it. So I go dot, 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 down, and then dot, 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 and then dot, 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 dot. That takes a little bit of practice, but if I can do it, I know you guys can do it. All right, you guys, so let's talk about this. We're going to solve the following problems. So in number 4, I want you to use the diagram in example 2. Now I copied it here so we could talk about it together. And I want you to count all the faces, edges, and vertices. So let's start with the faces, okay? So start with the base and shade that blue, and notice how the top, the ceiling, matches it. So I see 1, 2 triangular faces, and then count the walls going around. There's 1, 2, 3 rectangular walls. So 2 plus 3 makes a total of 5 faces. Now for the edges, okay, start at the base. Start at the base and count the edges. So I see 1, 2, 3 edges for the triangle, and then I start to go up. 1, 2, 3 edges going up, and then there's 1, 2, 3 edges for the ceiling. So 3 plus 3 plus 3 makes 9 edges. And then the vertices are the corner points, so I used my red on that. So I see 1, 2, 3 corner points at the base, and 1, 2, 3 corner points at the ceiling. So 3 plus 3 makes 6 vertices. Okay, and then on number 5, they want us to sketch a triangular pyramid. All right, and so I kind of broke it down for you step by step. So the first thing I do is I sketch a triangle for the base. The second thing I do is I just put a dot above the triangle. All right, and then the third thing I do is I connect the base to the dot. So I connect, connect, connect for the front face that I can see, and then I use the dot, 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 dot for the back, dot, 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 dot. And then in class, I'll tell you, we have to shade the base blue. So let's shade that base blue so they know that we just made a triangular pyramid. And then if we count the faces of our triangular pyramid, start with the base, so that's 1 face, and then there are 3 walls going around. So 1 plus 3 gave me 4 faces. Now the edges, again, start at the base. So I see 1, 2, 3 edges at the base, and then 1, 2, 3 edges going up. So 3 plus 3 gave me 6. And then the vertices, the corner points, I see 1, 2, 3 corner points for the base, and just that top point. So 3 plus 1 gave me 4. And then for the movie clue, I want you to tell me the name of the solid that's on example 2 that I crossed out. So tell me the correct name of that solid.